All right, in this lesson, we're going to again be looking at the unit circle. However, instead of looking at it with respect to the degree measures, we're going to be instead looking at it with radian measure used. So the unit circle is still the center. It has its center at the origin of the rectangular coordinate system, and the radius of the unit circle is still 1. Remember, one rotation around the circle, starts at 0, and then it ends up once you've made one full rotation. Once you're back at 0, you will have gone 2 pi radian. All right, so just looking at the first quadrant, again, we start off right there at 0 on the positive x-axis. And then if we were to go up 30 degrees, that 30 degrees is equivalent to pi over 6 radian. If we were to move up to 45 degrees, 45 degrees is, let's do the 60 degrees. 60 degrees is equivalent to 2 pi over 6 radian, which is the same thing as pi over 3 radian. And then now we can go back to 45. Not yet. So all the way at the top, at 90 degrees is the same thing as 3 pi over 6 radian. So if we simplify that, we get pi over 2 radian. And then lastly, 45 degrees is the same thing as pi over 4 radian. And then at the start point, at the positive x-axis, that is just going to be 0, or once we get all the way back, after one full rotation, it will be 2 pi. So the x and y coordinates for each one of those points is still the same. The only thing that has changed is, instead of degree measure, we're now using radian measure. Signs are consistent with the degree measure also. All right, so if we wanted to find the cosine of negative 180 degrees, negative 180 degrees is equivalent to negative pi radian. All right, so cosine of negative pi is the same thing as cosine of negative 180. And to find cosine of negative pi, we want to see where the terminal side of that angle is, and it points to the negative x-axis. So cosine of negative pi is just going to be negative 1. All right, secant of 90 degrees, we want to just change 90 degrees to radian. 90 degrees in radian measure would just be pi over 2. So we want to find out what secant is at pi over 2 radian. Secant is the inverse of cosine, and cosine of that angle measure is just going to be the x-coordinate. So secant is the inverse of that, so 1 over the x-coordinate 0 is just going to be undefined. And lastly, if we wanted to find the 6 trig ratios for 135 degrees, we want to first convert that to radian. 135 degrees in radian measure would be 3 pi over 4 radian. And that's where the terminal side would be located, forming a 45, 45, 90 degree triangle. And both legs of the 45, 45, 90 triangle are going to be pi over 2. Because all the x coordinates in the second quadrant are negative and all the y coordinates in the second quadrant are positive, sine of a 135 degree angle, which would sine of 3 pi over 4. Let's go ahead and correct that real quick. 3 pi over 4. Sine of 3 pi over 4 is pi square root of 2 over 2. And then cosine of 3 pi over 4 corresponds to the x coordinate at that point on the unit circle. All right, and that would be negative square root of 2 over 2. Tangent of 3 pi over 4 it is sine over cosine. So when I divide sine by cosine, I get -1. And then cosecant of 3 pi over 4 is the reciprocal of sine, so 2 over root 2. Once we rationalize the denominator, we just get root 2. Secant of 3 pi over 4 is the reciprocal of cosine. So that is going to be negative root 2. And then lastly, cotangent. Cotangent is the reciprocal of tangent. So cotangent of 3 pi over 4 is just going to be the reciprocal of -1, which is still -1.